So another problem which I have left. In a quadrilateral ABCD, angle B is 90 degrees. Angle B is 90 and angle D is also 90. What they are asking? 2 times AC square, that means join this one. 2 times AC square is equal to what? They are asking 2 times AC square minus AB square is equal to BC square plus CD square plus DA square. In triangle ABC, in quadrilateral ABCD, angle D is 90. Next, angle D is 90 degrees. What they are asking is, prove that 2 times AC square minus AB square is equal to this they are asking. So, I am doing Pythagoras theorem. Only few problems are left over from Serena publishers. I have covered all the models. So, I am continuing with the different types of models. Only few are left over. At most 2, 3. That's it. So, apply Pythagoras theorem for this triangle. ADC, square on the hypotenuse, is equal to sum of squares on the other two sides. AD square plus CD square. Consider triangle ABC, apply Pythagoras. Now consider triangle BAC. Consider triangle BAC, square on the hypotenuse. AC square is equal to sum of squares on the other two sides. AB square plus BC square. Add these two. AC plus AC is, see what we have to prove. AC plus AC is 2AC square is equal to AD square plus CD square plus AB square plus BC square. So bring this to here. 2AC square minus AB square is equal to AD square plus CD square plus BC square. So hence it is proved. So they may ask in exams different types, 2AC square, sometimes 2BD square, like that. They will ask in different formats. So the logic is same. Please try to do by yourself. Another question. It's very simple. This triangle you have to consider this triangle, add this. That's it. There ends the problem. Nothing great about this problem. It is nothing but objective type question. And another one. Important. Prove that sum of squares of the diagonals of parallelogram is equal to sum of squares of its sides. This I have done previously in the Pythagoras theorem by using different method. Now I am doing in another method. This is the benefit for yourself only. Whichever method you want to do, you can apply that one. Prove that the sum of squares on the diagonal. Prove that the sum of squares on the diagonals of a parallelogram prove that the sum of squares on the diagonals of a parallelogram is equal to sum of squares on its sides. Prove that the sum of squares on the diagonals of parallelogram. Sum of squares on the diagonals of a parallelogram. Which are the diagonals? AC square plus BD square is equal to what? Is equal to sum of squares on the sides. Which are the sides? AB square plus BC square plus CD square plus AD square. This we have to prove. So in order to prove this one, you need construction. Otherwise you cannot do this problem. Already I said this model can be I have done in different method. You can also refer to that problem as well as this one. This you write M, this you write M. Draw DM perpendicular to AB. Write on the step. DM perpendicular to AB and AN perpendicular to CD. Construction. So first step is construction. Already I said Without construction you cannot do this problem. Since we are in the end of session, I am explaining little bit fast. So DM is perpendicular to AB and CD is perpendicular to, AN is perpendicular to CD. Right? Therefore, see here. Now, what can we say is, this is parallel to this, right? So this is 90 degrees. So this also will be 90 degrees, right? What I am saying is, AB is parallel to CD, right? Angle N is equal to 90 degrees. So angle A is also equal to 90, because interior angles lying on same side of transversal is 180. In the same way, if this is 90, angle M is also 90. Angle D is equal to 90, angle M is equal to 90, right? Therefore, what can say? AMDN is a rectangle. Why it is rectangle? In a quadrilateral, if one angle is 90 degrees and the opposite sides are parallel, then it becomes a rectangle. Therefore, AMDN is a rectangle. Once again, a quadrilateral in which one pair of opposite sides are parallel, one pair or both pairs, both pair of opposite sides are parallel, and each angle is 90 degrees, then we can conclude that then we can conclude that quadrilateral is rectangle. So in a rectangle, opposite sides are equal, therefore AM is equal to DN and DM is equal to AN. DM is equal to AN. DM is equal to AN, right? So these things you write. This is very important. Before doing the problem, you should write all these steps. Construction: draw DM perpendicular to AB, draw CN perpendicular to this one. Therefore, AMDN is a rectangle. Why it is rectangle? This side is parallel to this side. One pair of opposite sides are parallel, and this side is parallel to this side, and also each angle is 90 degrees. At least one angle. A parallelogram in which one angle is 90 degrees, or more precisely, we can say, actually this is parallel to this, this is parallel to this, right? So it becomes a parallelogram. A parallelogram in which one angle is 90 degrees is a rectangle. Parallelogram in which one angle is 90 degrees is a rectangle. You write down all the steps what I have dictated. So therefore, AMDN is a rectangle. Now consider triangle. What we have to prove? AC square plus BD square. Keep in mind, AC square. So to do this, consider triangle ANC. Triangle ANC. Square on the hypotenuse is equal to AN square plus CN square, right? So AN square plus CN now will get this length, ND plus CD, DC plus ND. That is nothing but AN square plus DC square plus ND square plus 2 times DC into DN. Now this one is AC square is over, BD square. Consider triangle this triangle. Consider triangle BDM. Consider triangle BDM. Apply Pythagoras theorem. BD square is equal to what you will get? DM square. Square on the hypotenuse is equal to sum of squares on the other two sides. MB square. Right? So DM square plus MB. This length how will you get? This complete length minus this complete length minus AM square. So DM square plus AB square, AB minus AM, AB square plus AM square minus 2 times AB into AM, right? Now you have to add this and this, right? Add this and this. What you will get? AN plus ND. So AN plus DN. You see here. AN plus DN. AN plus DN square is nothing but AD square. So here AC square plus BD square is equal to what you can write? AN square plus DN square is nothing but AN square plus DN square is nothing but AD square plus 2 times DC into DN. Since AN square you can write here AN square plus DN square is equal to AD square. Next, this one AC square plus BD square we have written, no? So AB square plus AB square plus DM square plus AM square. DM square plus AM square. Is it clear what I am writing? AC square I want AC square plus BD square is equal to this one AD square. How I got AD? Because I clubbed this and this. Here in brackets I have written plus AB square right as it is. It is AB square from here. I am adding these two AB square plus DM square plus AM square. What is DM square plus AM square? DM square plus AM square. DM is nothing but AN. Already I have written. So in place of this you can write here, or else what you do is you write here AD square plus, here itself you write down AN plus ND is AD square plus CD square I have written. So CD square plus 2 times like this. Here itself you write down AD square plus DC square. Instead of writing here itself you write down. So AN square plus ND square is nothing but AN square plus ND square is nothing but AD square plus CD square plus 2 times DC into DN. Next, this one. What I am saying is you write down, simplify this one. Here itself you simplify. AM square, AM is nothing but DN. So in place of this AM, I want to write DM plus AB square. DM is nothing but AN minus 2 times AB. This AB is nothing but, in a parallelogram opposite sides are equal. AB is nothing but CD into AM. AM is nothing but DN. Once again I am explaining this one clearly. Please understand this step carefully. AM, here it is DM is given. DM is nothing but AN. In place of DM I have written AN. AM is nothing but DN. So in place of AM I have written DN. Since opposite sides of a rectangle are equal. AB, in place of AB I have written CD. Opposite sides of a parallelogram are equal. DN, in place of AM, why I have written DN? Opposite sides of a rectangle. Write down all the steps. Therefore, AN square plus DN square. AN square plus DN square is nothing but again AD square. AD square plus AB square minus 2 times CD into DN. This problem is little bit confusing. Why? Because we have to apply properties of rectangle as well as properties of parallelogram at a time. So this is what we will get. Now we have to add these two. AD square plus AB square minus 2 times DC into dm. DC into dm. 2 dm DC gets cancelled. You have to add these two. So AD square plus CD square plus AD square plus AB square. So here AD 2 times I have written, no? AD. So AD is nothing but BC. BC square plus CD square plus AD square plus AB square. So see here, AB, BC, CD, AD. There ends the problem. So first part is very simple. Second part, while doing second part, be careful what I am writing. DM is nothing but AN, opposite sides of a rectangle. AB you have to write as it is. AM is nothing but DN, opposite sides of a rectangle. Minus 2 times CD into DN. Here AB is nothing but opposite sides of a rectangle. AB is nothing but CD. AM is nothing but again DN. This side is equal to DN. So why I have written? Because I want to cancel these two. So AD twice it is given, but AD is nothing but BC. So in place of AD I have written BC, CD, AD, AB. There is the problem. Very lengthy problem. Opposites, parallelogram properties, rectangle properties I have applied. It's very simple. Thank you students. Have a nice day. Please click on the blue color icon button to subscribe my channel. Thank you. Share with your friends. Thank you.